This starts section 7.3, the algebra of functions. And so this is where we're going to create new functions given functions. So let's start off with here. I've kind of divided this note sheet. If you want to print off the note sheet, you can, into two portions here. This is two separate problems. Something like that. So let's start off with what makes a relation a function. A relation is a function if it has exactly one output per input. It also passes the vertical line test. So in everything that we do in this unit, we're going to be creating brand new functions by either adding two functions, subtracting, multiplying, dividing, and we're doing what's called the composition function. So we're going to start off with, so this is two separate problems here, problem 1 and problem 2. So I've got two functions, f of x and g of x. What I want to do is think about evaluating certain places given these two functions. So this would be something that would have to be given to you. The question might say, evaluate f of 3, or evaluate f of 0, or evaluate g of 5. So let's think about this first one. If I want to evaluate f of 3, that means I want to use the f function, but I want to put 3 as the input value. So since the f function is 2 times the input, it's going to be 2 times 3, which is 6. So I could say that f of 3 equals 6. So if I graph this function, there would be a point 3, 6 on that function. What if I was asked to find f of 0? I would use the f function and put 0 as the input value. So f of 0 is 0. Those are just points that we would find on the graph. What about g of 5? This time I'm going to use the g function, and I'm going to put 5 as the input value, and the function is input add 1. So g of 5 would be 6. So sometimes when you're evaluating, they give you the function and you just have to evaluate a place. Sometimes you're given the graph. Notice this graph, I have an f function and I have a g function. It's not the same as what we just did. These are two different functions. So what if we were asked to evaluate given a graph? So let's just make up some problems here on this one. Let's find f of 3. Let's find g of 2. Let's find g of x equals 0. And let's find f of 4 equals 3. Oops. Let's find f of 4. Okay. So this time I'm going to look at the graph to evaluate the function. So I'm going to start with f of 3. So I'm going to have the f function and the input value is going to be 3. The f function is this pink function. So what I want to do is evaluate this function whenever the input value is 3. So when the input value is 3, the f function is right here at 1. What about the g function at 2? The g function is this function. So I'm going to go to input value of 2, and when I put 2 in and go all the way up here to the g function, I'm at the place 3. The next one tells me the output value, and I have to go backwards and find the input value on g. So the output value is 0. So where does g equal 0? Where's the y value equal 0? Right here. It also equals 0 right here. So this happens when the input value is 5 or when the input value is 7. It happens at both places. Okay, let's find the last one. The f function when the input value or the x value is 4. So when I go 4 for the x value, then the y value is 3. So we're talking about inputs and outputs. All right, let's go down to the next one. We're going to graph this function. And again, this one is a piecewise function. See how it has 3 parts? And the parts kind of break up at different input values. Here, when the input value is smaller than -1, the graph is going to look like this. When it's between -1 and +2, it's going to look a certain way. And when it's bigger than 2, it's going to look a certain way. So let's just start with this one. I want to graph when x is smaller than -1, I'm going to graph the function 2x plus 3. So I'm going to start at -1 and then pick numbers smaller than -1. If I put -1 in here, 2 times -1 is -2, plus 3 is 1. So at -1, I'm going to be at 1. This is an open circle because there's no line under it. Okay, let's try -2. 2 times -2 is -4, plus 3 is -1. So at -2, I'm at -1. What about -3? 2 times -3 is -6 plus 3, which is -3. So this part of the graph looks something like this. It did not go down correctly. Should be -3, -3, like this. Okay, think about this one. This is the function y equals x squared, and it's going to happen between -1 and 2. So I'm going to pick numbers between -1 and 2, like 0 and 1, and I'm going to put them into the function x squared. -1 squared is 1, so that's right here. 0 squared is 0, that's right here. 1 squared is 1, and 2 squared is 4. So it looks something like this. And then the last function, where x is greater than 2, is at y equals 4, so it looks something like that. So we've created a new function by piecing together 3 different functions, and that's a piecewise function.